Hello class, this is lesson number 2 for the week of April 27th. Okay, so today we're going to be talking about adding polynomials. So if you remember from the last lesson, we talked about what a polynomial was, the various types, how to determine the degree of a polynomial. So let's kind of review that. Okay, so here we go. It says determine whether each expression is a monomial. So if you remember correctly, with a monomial was the simplest type of polynomial you could have. And a monomial was a number or a product of numbers and variables as long as the exponents are whole numbers. Okay, so there were a few cases where it wouldn't be a monomial. Okay, and if it's not a monomial, then it can't be a polynomial. So we found out that if the exponent was not a whole number, then it's not a monomial. If the exponent is a variable, then it's not a polynomial or a monomial. If there is a variable underneath the radical, it can't be a monomial. And if there's a variable in the denominator, it can't be a monomial. Okay, so let's see if we can identify each of these as being a monomial or not. Number 1, negative 2x squared y. Is this a monomial? Yes. Okay, we'll notice that it's just the product of letters and numbers, and my variables on my my exponents on my variables are whole numbers. It's perfectly fine for this number out here to be a negative number. Okay, it's just the exponent can't be negative. Number 2, 4 divided by 3x. Is this a monomial? No, because we have a variable in the denominator. Okay, so if this x is 0, then that would be 3 times 0, which is 0, and we would have division by 0. Okay, and you know you can't do that. Number 3, the square root of 3x, is that a monomial? No, it's not. Okay, again, because we've got a variable underneath the radical. And then number 4, is 9 a monomial? Yes, because if you remember in the definition, it says it can be a number or the product of numbers and variables. So that would be a monomial. Excellent. Okay. Now 5, 6, and 7, it says classify each expression as a monomial, binomial, trinomial, or not a polynomial. Okay, so if you remember from the lesson last time, it says a polynomial is one monomial or the sum or difference of monomials. Okay, so if it has one term, then it's a monomial. If it has two terms, then it's a binomial. If it has three terms, it's a trinomial, and each term is just a monomial. Okay, so let's see. 3/4 x plus y, is that a monomial, binomial, trinomial, or not one? That would be a binomial. First thing you have to do is you've got to make sure that each term inside your so-called polynomial is a monomial, which means it has to meet those conditions. So 3/4 x is perfectly fine. The number in front can be a fraction. It's just the exponent on your variable cannot be. Okay. 6, 5r minus 3r squared plus 6. Are each of these monomials? Yes, they are. So this one here would be a trinomial because there are 3 terms put together with plus or minus. Okay, 3 divided by x squared plus 2x. Okay, well, this term right here is not a monomial, so it's not going to be a polynomial. So this x squared in the denominator messes things up, so this would be a not one. Okay, and then this 2, okay, well, there's only one term there, so this one is a monomial. And then the last thing that we had to do from last lesson was find the degree of each polynomial. Okay, so if we were to go back and look at what the degree was, if you remember, the degree was like king of the hill. Okay, so you find the degree of each monomial, and to find the degree of each monomial, or the degree of a term, it's the sum of the exponents of the variables in that term. So you look at the exponents that are on the variables and you add those together. That will give you the degree of each term. And then to find the degree of the entire polynomial, it's the monomial that has the highest degree. So in this example that we had, this was to the 2nd degree, 5th degree, 2nd degree, because you remember this x had a 1, this y had a 1. Add those together, you get a 2. And then if you have a single number, 5, that's a degree of 0. If you have a 0, then there would be no degree. Okay, so this one's 2, 5, 2, 0. So who's the strongest? The strongest is 5, so the whole thing is 5. So we come back and look at this one. We got negative 7m to the 5th, so we look for the degree of each one. This one is 5, this one is 8, so the whole thing is to the 8th degree. This one is 4, this one is 0, so the whole thing is to the 4th degree. 52, there's no exponent, there's no variables, and there's no exponents on those variables, so this one is to the 0th degree. Okay, and that's how we found whether or not, one, it was a monomial. Okay, and if you had a series of monomials, then you could either have a binomial, trinomial, or not a polynomial if one of the terms happens to be not a monomial. And then we found the degree. Well, today what we're going to do is we're going to look at adding polynomials together. Well, in order for us to do that, we've got to go back and look at one very important concept. So it says organize this page. Okay, so many of you have very good organizational skills, and organize means put like things together. So on this page right here, I would take this 2x squared and this 4x squared, and I'd put those together. Okay, and when I put them together, that makes it 6x squared. Okay, I would take this 5y and maybe this y right here, and maybe this negative 6y, and put all those together because those all have a common thing, a y. Okay, this 4x and this negative 2x and this x I'd put together because they all have an x. And then I would take the negative 5 and this 7 and this 3, and I'd put all those together because they also, none of them have variables, so they have a common thing. Okay, so by putting all this together, this is what we call combining like terms. Combining like terms is putting like things together. Things that have something in common, we put those together. And when we put that together, we always put it together with addition. So if I were to put all this together, this right here gives me 6x squared plus, and then this 5y plus this 1y here gives me 6y, plus the negative 6y gives me 0y. So these actually cancel each other out. The 4x and the x make 5x, and I take away 2 of them, I get 3x, plus, and then the 7, the negative 5, and the 3, well, let's see, 7 and 3 make 10, take away 5 gives me 5. So I actually put all the like terms together, and this is what I have left, and this becomes a trinomial. Okay, and that's what we're talking about by combining like terms. It's a very important concept when we're adding polynomials together. Okay, so you're going to need that definition a little bit later on in order to work on your assignment about combining like terms, because your writing prompt today is, what do I mean by combining like terms? And you need to write something to the effect of, combining like terms means putting like things together, and we put it together through addition. Now, what we're going to do for the rest of this lesson is we're going to learn how to add polynomials. And what you have to understand about adding polynomials, all we're doing is combining like terms, putting like things together. So here is an example of that. Okay, so what we have here is we've got 5x cubed plus x squared plus 2 plus 4x cubed plus 6x squared. Okay, now since everything is plus right here, okay, I'm ready to go. It's really good. Okay, that's what I want. I want everything to be plus. Okay, so the first thing I do is I look inside this right here, and this one is what I'd call a trinomial, because each one of these, since we're adding polynomials, they're all going to fit the definition of being a polynomial. And I'm just going to put like things together. There's not anything in this one that I can put together, but everything is plus, so it's all good. So I look in this one. Is there anything I can put together there? No. And it's plus. So if everything inside this first set of parentheses is plus, and everything inside the second parentheses is plus, my parentheses really can just go away, and I just add like things together. So I look in this one and I see 5x cubed. Do I have any other x cubes that I could put together with that? I've got 4 of them over here, so I can take the 5x cubed and the 4x cubed and put those together to give me 9x cubed plus, and then I can cross those out. And here I've got an x squared, which is really a 1x squared. Now I have another x squared over here, so 6x squared and 1x squared make 7x squared. Plus, and those can cross out. And then what do I have left? I only have a 2 left. So when I added these two polynomials together, this trinomial with this binomial, I ended up with a trinomial, and I ended up with 9x cubed plus 7x squared plus 2. All right? So let's try another one. Okay, so in this one right here, I've got another trinomial and a binomial, and I'm going to add those together. So step number one when you're doing this is you look inside the first set of parentheses, make sure everything is plus. And it is, so it's all good. Step number two, look inside the next set of parentheses, make sure everything is plus. Okay, so this one right here, oh, it's minus, so we know we're going to change this minus to a plus, next number to its opposite. This just allows for my parentheses to go away, and I just combine like terms. So I start here, and what I like to do is I like to start with one polynomial and just work my way all the way through it until I have nothing left. So here we've got 6x cubed. Do I have any x cubes that could go with that? No, I don't, so I just write it down, 6x cubed. Plus, and I cross that one out. And I got 8y squared. Do I have any other y squareds that can go with that? I do. I've got a negative 2y squared over here. So 8y squared and negative 2y squared give me 6y squared. Plus, and again, I can cross those out if I want to. Okay, and then I've got a 5xy and a 4xy. Well, this one's got an xy container. This one's an xy container. So those are alike. Okay, just because this one's got an x, it doesn't go with the xy. Just because this one's got a y, it doesn't go with the xy. xy's go with xy's. So 5xy plus 4xy gives me 9xy. So I've got x cubed plus 6y squared plus 9xy would be the sum of this polynomial. Now let's do one more, and then we'll have you do some on your own. Okay, so here we go. Now this one's kind of interesting. This one's got a binomial, and a monomial that we're going to add together. So again, the first thing I do is I look inside my parentheses. Okay, I make sure that everything's plus. So this one right here is a minus. I'm going to change that minus to a plus. Next number to its opposite. This one's good, and this one's good. So everything is good, so now I'm ready to add. Okay, so I start here. I've got 3x squared y's. Do I have any other x squared y's that will go with that? Yes, I do. I got 6 of them here. So 3 of them and 6 of them make 9x squared y plus. So those can be canceled out. Then I got a negative 5x and a 4x. Those can go together. So negative 5x and 4x give me negative 1x, or just negative x. Okay, so those go away, and then I'm left with plus 7. Now another way of writing this, and the way you would actually see it in a book, would be 9x squared y minus x plus 7. Because this plus minus plus negative, we would actually change that to a minus. Okay, and this would be the sum of those polynomials. Now what I'd like to do is I want to have you do some. Okay, we're going to have you do just a couple by yourself. Okay, I'll let you do it. You'll pause the video, and then I'll come back and let's make sure that we have the right answer. So here's the first one I want you to do. Please pause the video and add these two polynomials together. Okay, so let's see how you did. Okay, so first off, I look inside my parentheses. Everything's plus. Everything's plus. So now I put like things together. So 3y to the 4th. Do I have any other y to the 4th that'll go with it? I do. I've got 5 of them over here. So that gives me 8y to the 4th, because 3 and 5 make 8. Cross those out. I've got 1y squared here, and I got another 2 more y squareds over here. So that gives me plus 3y squared. So those go away, okay, and then plus, and then all I have left is 6. So that's what you should have come up with. Excellent. So let's do one more, okay, and then I want to show you another method of working these real fast. Pause the video and add these two polynomials together. Okay, let's see how you did. So look inside this set of parentheses. It's all good. This set, not good. So I change this subtraction to addition, the 3p squared to a negative. So now I start combining things that can go together. Do I have any other x cubes? No, I don't, so I just write down 9x cubed. Cross that one out. Do I have any other p squareds? Ah, yes, I do. I got some p squareds over here. So 6p squareds and negative 3p squareds give me 3p squared. Okay, plus, and then those go away. Okay, now do I have any other xy's? Yes, I got 3 of them here. I got 8 of them here, so 8, 9, 10, 11. So I end up with 11xy. And this would be the sum of these polynomials. Okay, so that's how we add them together horizontally. Okay, now sometimes you're going to have them vertically. It says you can also add polynomials in a vertical format. Write the second polynomial below the first one, lining up the like terms. If the terms are rearranged, remember to keep the correct sign with each term. Okay? So here we go. Now what we're going to do with this one now, in order to write them up and down, the first thing that we need to remember is we've got to have everything plus before we can change it. So I look inside this one, everything's plus, it's all good. Everything's plus, it's all good. So what I'm going to do is I'm going to take this second one, I'm going to write it underneath the first one according to like terms. So this 2x squared is going to go underneath my 4x squared. Okay, and then my 6x is going to go underneath the 2x. Okay, and my 9 is going to go underneath the 11. Okay, so now what we're going to do is we're going to add them vertically like this. Now the nice thing about this is that everything is already lined up nice and neat for us. So the 11 and the 9 make 20, plus the 6 and the 2 make 8, plus, and the 4x squared and the 2x squared make 6x squared. Now it's up to you as to whether or not you want to actually do it this way. I like it the horizontal way just fine. But you will see a few problems on your assignment that are written in the vertical format. But they've already been written vertically for you. Okay, so let's look at one more real quick. Okay, one more kind of crazy one. Let's look at this bottom one here real quick. Okay, so kind of look at this one. So I'm going to write this one kind of up above, and I'm going to rewrite. We'll start with this one. Well, no, I'm going to just copy it underneath. Okay, so here I've got a, no, actually I'm going to rewrite. This was just going to be too difficult to not rewrite. So I'm going to write negative x squared y squared plus 5x squared. Okay, and then I've got negative 2y squared plus 2. What does that go with any of those? That doesn't go with any of those. Okay, so I'm going to just do this one down here. So plus negative 2y squared plus 2. Now this x squared, do I have any x squareds? I do have an x squared right here. So I'm going to write that x squared underneath this one, plus, and then this 8 goes underneath this 2. So this one's kind of a crazy one right here because we've got some various things that are kind of funky in this one. So this one right here, you'd bring this negative x squared y squared down because it doesn't have a partner, plus, and here I got a 5x and a 1x squared. So 5x squared and 1x squared give me 6x squared, plus, and then this one here, it didn't have a partner, so negative 2y squared, plus, and then the 2 and the 8 make 10. Now for me personally, writing it vertically makes this one a little bit more difficult. I'd like to just write it down and cross them out as I go. But you need to know that that is a possible way of doing them. So what we've looked at today really is just adding polynomials together. Now there is one last problem I want to kind of look at real quick before we end this video, and it is this one right here. So sometimes we have this as an application. It says the base of an isosceles triangle. Now isosceles, immediately you should be thinking about, two sides alike in a triangle. The base of an isosceles triangle has a length of x plus 4. Okay, so x plus 4. Okay. The two legs of the triangle have lengths 3x plus y. So this one is 3x plus y, and this one is 3x plus y. It says write an expression for the perimeter of the triangle. So this one would be, x plus 4 plus 3x plus y plus 3x plus y. So the perimeter would be all of this added together. So again, you just put all your x's together. So here's an x, here's 3x, here's 3x. So you put all that together, you get 7x plus, okay, and then this one is a 4 and a y. So my x's are all together. So now I'm going to do my y. So y and y make 2y, okay, and then plus the 4. So 7x plus 2y plus 4 would be the perimeter of this particular triangle. So sometimes you've got to actually, kind of think about what it is that you're doing and apply multiple concepts to a single problem. Okay, now what you're going to do in your assignment today is something very similar. It says find the sum, write the sum in the space provided. Okay, so what you're going to do on the form is you're going to type it in for me. Okay, you're just going to type in what it is that you're going to add together. So this one right here, we know we got 5w squared and we got another w squared, so you got 7w squared plus, and then 8w and 3w give you 11w. So the way that you would type that into the form would be 7w, then you would use that little up arrow thing, 2, and this up arrow thing is above the 6, so you do shift 6 to get to that, plus 11W. And I don't want you putting any spaces in between anything, because in the form that I'm going to be using, that's how I'm going to be checking your answer. Okay, so just kind of keep that in mind. Okay, that's what I want you to do on this particular assignment. So on this first one right here, like I said, we had 5W squared and 2W squared, which gave you 7W squared, plus 8 and 3 gave you 11W. Well, the next one, you got to remember, I've got to change this subtraction to addition next to its opposite. So we got 3x squared and 2x squared, which would give you 5x squared, plus, and then you got a negative x and a 3x, which would actually give you a 2x. Okay, and then this next one, the same kind of thing. Okay, I go into this set of parentheses, I change this one. I go into this set of parentheses, I change this one, and then I start putting like things together. So this x squared and this x squared actually make 2x squared, plus this 3x and this 5x make 8x. And then this negative 10 and the negative 14 make a negative 24. And you can write that as plus minus or just minus 24. Okay, it's strictly up to you. Now sometimes crazy things will happen, like on this one right here. Okay, I change this one right here. My x and my x go together to make a 2x, but what happens with my negative y and my y? Well, they make 0y. Well, that'd be kind of silly if you did 2x plus 0y. It's just 2x. So sometimes things may go away. Kind of like on this next one here. I change this right here just like I'm supposed to do. So I've got a 4 and a 1 that could go together to make a 5. And then this negative 3x and this positive 3x, well, that's going to make 0x. Okay, so, and we don't put a 0x, we just put nothing, because, you know, anything that's represented 0, you just put either 0 or you don't put anything at all. So the answer to number 5 is just plain old 5. Now I've actually worked 5 of these, just seeing if you will watch the video. Okay, and then on the last ones, what you're going to do, I've given you 3 that are written vertically. Now, like number 11 right here, the 2x plus 4, well, I come down to this one, just kind of imagine those in parentheses. So I'm going to fix this right here. Okay, and then I want to just add them together. The 2x and the x make 3x, and the 4 and the negative 7 make negative 3. So you'd end up with 3x plus negative 3. So you would type that into the form as 3x plus minus 3, or 3x minus 3. Either one would be acceptable. Okay, so what we learned today is how to add polynomials. We know adding polynomials is nothing but combining like terms. So you'll notice down here in this sentence it says in a sentence or two, okay, that should be an or. In a sentence or two, what does it mean to combine like terms? Well, combining like terms means putting like things together. Okay, and please make sure that when you're doing the writing that you're giving me a complete sentence. I'm going to start taking off points if you don't do that. So until next time, I'll talk to you later.